Hi everyone, we're looking at notes 5.7, which are on the bottom of page 9, and we're going to fill in what x-intercepts of quadratic relations are. So remember, the roots are where the parabola right here, these are our roots right here, they're always where the parabola crosses the x-axis, okay? But in other words, this is where y is going to equal 0. So this is just some review on what we talked about in class the other day. So let's take a look at what we have right here for number 10, or page 10, number 1. It says find the roots of the following parabolas. So the way we need to do this, if you guys remember, we need to factor. And when we factor, there are 3 different ways we learned how to factor. We learned that we could factor by GCF. We learned that we could factor by a difference of perfect squares. And we learned that we can factor by unfoiling. Okay, so let's take a look at number 1. Number 1, first thing we're going to do is we're going to plug 0 in for y. So we get 0 equals x squared plus 4x plus 3 right here. So then what I'm going to do is I'm going to identify what type of a factoring problem this is. So the GCF, it's a GCF question if there's something in common, but there isn't anything in common with all 3 terms. So it's not a GCF question. It's not a difference of perfect squares because there are 3 terms. It's not an unfoil question, or sorry, it is an unfoil question because if you look right here, we can use x times x gives us the x squared, and then here we could use 3 times 1, and 3 plus 1 gives us the 4 that we want. And if you want to use the box, go for it. I'm not going to use the box so much anymore, but you absolutely can use the box if you want to. Now, in order to be able to do this right here, remember when we said 2 things are multiplied together to give us 0? One of those 2 things has to be 0. So I'm going to set each part equal to 0. So x plus 3 equals 0 and x plus 1 equals 0. Okay, so that means x equals -3 and x equals -1. So those are the roots of my parabola. Okay. All right, in number 2, this one is really tricky. I want you guys to put a star next to this one, and I want you to look back at this one in the future when we go over some other questions. I don't want a negative here, so I'm going to factor out a -1. And when I do that, this negative x squared becomes positive x squared. This 8x becomes a negative 8x, and this -12 becomes a positive 12, because a negative divided by a negative is a positive divided by a negative is a negative, and a negative divided by a negative is a positive. So I'm also going to replace this with 0 to find my roots. So I'm going to get 0 equals -1 times x minus and x minus. And I know they're both minus signs because 2 negatives multiply together to give me positive 12, and 2 negatives added together will give me -8. So I can do x minus 6 and x minus 2. Now I set each part equal to 0. So I set -1 equal to 0, which is not possible. -1 will never equal 0. I set x minus 6 equal to 0, and I set x minus 2 equal to 0. Well, to solve for x here, I would add 6, so x equals 6. And to solve for x here, I would add 2, so x equals 2, and those are my 2 roots. Okay? All right, so for number 3, again, I'm going to set it equal to 0, so I'm going to say 0 equals. And then I'm going to look right here, I've got x squared minus 4x. And if there is a GCF, I'm going to factor it out. So when I take a look at both terms, there's an x in common. So this is a GCF question. So I get 0 equals x. And then in brackets, I'm going to say x minus, because x squared divided by x, remember we subtract our exponents. So when we subtract 2 minus 1, we get 1. And then 4x divided by x, the x's cancel, so I get 4. Set each part equal to 0, so I get x equals 0 here, and I get x minus 4 equals 0. This is one answer because the x is alone. Here, I need to add the 4 to both sides, so I get x equals 4. Okay? All right, now for number 4 right here, I need to set 0 equal to y, and then I get x squared minus x minus 20. There's nothing in common with all three terms right here, so it's not a GCF question. It's not a difference of perfect squares because there are three terms, so I'm going to try to see if I can unfoil it. Okay, so I'm going to use the box for this one. So I'm going to fill in that this is x squared, this is negative 20, and I know this has to be negative 1x. So right here, I know that this is going to be an x and an x, because x times x is x squared. Now here, for this one and this one, those numbers have to multiply together somehow to give me 20. So let's make a list. So I can do 1 times 20. I know 20 is divisible by 2, so I could do 2 times 10. I know 20 is divisible by, I know 20 is not divisible by 3, so I'm not going to include it here. And I know 20 is divisible by 4, and I get 5. And I'm looking for the number that's going to give me a 1 somehow, and the only way I can get that is from a 4 and a 5. So I'll put a 5 here, and I'll put a 4 here. It does not matter where you put them. But I want to get a negative 1, so this has to be a negative 5, which means this is negative 5, and this is positive 4. So that means I end up getting x minus 5 times x plus 4. Okay, so now that I've done that, I can set each part equal to 0. Like I said the other day in class, you can just go straight to noticing that it's just the opposite sign. This is positive 3, this is negative 3. This is positive 1, this is negative 1. This is negative 6, so our actual x value is positive 6. So here x equals 5 and x equals negative 4. And those are my answers. Okay? We're going to skip 5, and I want to take a look at number 6. So number 6 right here, we can see that there is no GCF because there's nothing in common. It's a difference of perfect squares because we've got two perfect squares, we've got subtraction, and there's two signs. So, there's two terms, excuse me. So I'm going to set 0 equal to, and I'm just going to factor x squared minus 9 into x plus 3, x minus 3, which means x has to equal negative 3, or x has to equal positive 3. Okay? So now, to graph a parabola in standard form, the following is needed. This is everything that we talked about the other day in class. So here's a summary of everything that you need right here. So let's go ahead and apply it to the next question. I'm not going to actually go through and read this to you guys because you guys know how to read. Okay? So let's take a look at what we have here. So it says graph the parabola defined by this equation right here. So step 1, factor the equation to find and plot the roots. So we're going to find the x-intercepts right here. I'm going to go ahead and write out right here 0 equals, and then I'm going to look through my list of questions right here. So is it GCF? There is nothing in common with any of these three terms, so it's not a GCF question. Is it a difference of perfect squares? There are three terms, so that's not possible. So I'm going to try to unfoil. So when I unfoil, I'm going to use x and x. And the numbers that multiply together to give me 5 are just 1 and 5. So I'll use a 5 here and a 1 here, and I can get both of them to give me negative 6 by adding if they're both negative. So that means that my roots are going to occur at x equals 5 and x equals 1. Okay? So let's go ahead and set up our axis right here. I don't know how I need to space out my y-axis yet, but I do know how I want to space out my x-axis because I've got my roots here. So my roots are 5 and 1, so I'll just go by 5s, or go by 1s. So 1, 2, 3, 4, 5. I'm not going to label every single one, but each block represents 1. So I've got negative 5 here, negative 10 here. So 1, 2, 3, 4, 5 here, 10 here, 1, 2, 3, 4, 5 here, negative 5, and negative 10 there. So my two roots were at 5 and at 1. Okay, so now find the axis of symmetry. It's the midpoint between the two roots. Just a reminder, you just have to average the two roots. And to find an average, we add up our two numbers, so 5 plus 1, and divide that by 2. So 5 plus 1 is 6. 6 divided by 2 is 3. So if I take a look right here, I can see that my axis of symmetry occurs when x is equal to 3. Okay, notice how this is right at 3. All right, the next thing we're going to do is we're going to plot the y-intercept. And I apologize, I said I wasn't going to scale out the y-axis, but I did anyway, so hopefully it will fit. We might have to adjust the scale. So for the y-intercept right here, I'm going to find the y-intercept by simply just finding out what c is. So the c value right here is this last number right here, which is 5. So my y-intercept is 0, 5. So right here, I'm going to go to 0, 5, and that's my y-intercept right here. Okay? Step 4 says to plot the y-intercept reflection point. Now this step is new. We did not do this the other day in class. So if you guys notice right here, what I'm going to do is, it's 3 steps to the axis of symmetry, so that means that the reflection point is 3 steps away. So here's where my reflection point is going to be. Okay? All right, now step 5 says to determine the optimal value. Pretty much, we're just trying to find the vertex. So it's pretty much the vertex's y value. Okay, so we figured out here that our vertex is going to occur when x equals 3, or our axis of symmetry is going to occur when x equals 3, and we know that the equation is going to be y equals x squared minus 6x plus 5. So I'm going to say y equals 3 squared minus 6 times 3 plus 5. And when I evaluate that, 3 squared is 9, 6 times 3 is 18, plus 5, so 9 minus 18 is negative 9 plus 5, so y equals negative 4. Okay, so then it says to plot the vertex, but the vertex is x comma y for the axis of symmetry and the optimal value. So our axis of symmetry is 3, our optimal value is negative 4, so our vertex occurs at 3, negative 4. So I'm going to go to my graph, and I'm going to go to, I'm going to go to 3, 1, 2, 3, negative 4, and this is where my vertex is going to occur. Okay, and it's always going to be on the axis of symmetry. Step 7 is to draw a smooth curve between all points and use the step pattern if necessary. I want to just remind you guys about the step pattern. So the step pattern is always going to be 1A, 3A, 5A, so on and so forth, okay? And our A value here is 1. So our step pattern is 1 times 1, which is 1, 3 times 1, which is 3, 5 times 1, which is 5. So our step pattern is 1, 3, 5, so on and so forth. So let's see if this works. So I go over 1 and up 1 because my first step is 1. Then I go over 1 and up 3, and there's my root. Go over 1 and up 5, and there's my reflection of my y-intercept. So it works. It goes through all of my points that I need it to go through. So if I take a look at this right here, if I connect my points right here, I've got my parabola, y equals x squared minus 6x plus 5, and I'm good to go for that question. Okay? One more example that we're going to take a look at. That's example number 2. So this one right here, I'm telling you that we can label the axes by going up by ones. It will fit for us. Sometimes we have to find all the values first before we figure out how we want to space it out, but that will come with just some practice, okay? So if you take a look at what we have here, it says we've got the parabola y equals 2x squared minus 8x. So the first thing I'm going to do is I'm going to factor the parabola. I'm going to plug in 0 for y. Okay, so don't forget that we have to go through 3 steps. It's either going to be a GCF question, it's going to be a difference of perfect squares question, or it's going to be an unfoil question. Okay, so is there anything in common with both of those terms? Yes, there's a 2x in common. So I'm going to factor out a 2x, and 2 divided by 2 is 1. and x squared divided by x to the power of 1 is x to the power of 1. And then negative 8 divided by 2 is negative 4, and our x's cancel. So if I set each part equal to 0, this is saying 2x equals 0. Divide both sides by 2, so I get x equals 0. And here we just know we can just do the opposite sign and x equals 4. We can't do the opposite sign here because it's multiplication, so we divide by 2. So that means my two roots are x equals 0 and x equals 4. So I know that at 0 we have a root, and at 4 we have a root. Okay? To find the axis of symmetry, remember we are just finding the average of our roots. So I'm going to add 0 plus 4, divide that by 2. So I get 4 divided by 2, which is 2. Okay? So that means that my axis of symmetry is going to occur right at x equals 2. So I'm going to draw in my axis of symmetry. Okay? All right, now we need to plot the y-intercept, and the y-intercept happens at C. And if you notice here, nothing is being added on. This is plus 0, so C equals 0, so my y-intercept is at 0, 0. So if you notice right here, my y-intercept is already there. Okay, now we need to plot the y-intercept reflection point right here. So the reflection point, it's 2 steps to the x-axis, or to the axis of symmetry, so 2 more steps, but it's where the root is, which should make sense because the axis of symmetry is halfway in between anyways. Okay? Plot 5 says to determine the optimal value. So we figured out here that our axis of symmetry occurs at x equals 2. And our equation is y equals 2x squared minus 8x. So I'm going to say 2 times 2 squared minus 8 times 2. And 2 squared is 4, so I get 2 times 4 minus 8 times 2. And here I end up getting 8 minus 16, so y is negative 8. So when I plot my vertex, it's always the axis of symmetry followed by the optimal value. So my vertex is 2, negative 8 right here. So if I take a look at what I have here, I'm going to go to 2, negative 8, and I will see that that's where my vertex is going to be. Okay? All right, last thing I need to do is draw a smooth curve and use the step pattern if necessary. So for my step pattern right here, let me get a different color. So for our step pattern, again, it's 1a, 3a, 5a, so on and so forth. Here, our a value is 2. So that means that I'm going to get 1 times 2, 3 times 2, 5 times 2, so on and so forth. So 1 times 2 is 2, 3 times 2 is 6, 5 times 2 is 10. So if I look right here, I'm going to go to the right one and up 2. That works. I'm going to go to the right one and up 6. 1, 2, 3, 4, 5, 6. I've got a point here that works. Go to the right one and up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've got a point right here. And then I can just reflect that over my axis. So 1, 2, 3 steps to the axis. 1, 2, 3 steps to my point right here. Connect all of my dots. Sorry, I've got a reflection point right here, so this is 1 step away, so this is also 1 step away. So then this is my parabola right here, y equals 2x squared minus 8x, and I'm good to go for this question. Okay?